Hello, geometry, and welcome to the start of topic 2, parallel and perpendicular lines. In this lesson 2, we're going to focus on parallel lines. Let me show you one of the most general pictures involving parallel lines that you will see over and over again. It looks something like this. You have two lines. Typically, we label them as L and M. So if you remember from our very first lesson that you can name lines with a single lowercase letter by an arrow. To mark them parallel, you would put arrows on them. And then typically we have what's called a transversal going through those two lines. Typically it's able T for transversal. And what we would say is that we would say L is parallel to M with transversal T. So this is our example of parallel lines that you might see over and over and over again. I think you should have seen this in the past. Okay. All right, so example one, identify some angle pairs. Identify the angle pairs of each type made by these snowmobile tracks. So our corresponding angles. So our corresponding angles are in the same position at the two intersection points. Position. So we have two intersection points here. Let's call that A, and here, call that B, right? Uh, if we want to take a look at this picture more, so here's our L, line L, here's our line M, here's our transversal, right? So we would say L is parallel to M, right? Parallel. So in this picture here, to find corresponding angles, I'm looking for angles that are in the same position at A and the same position at B. What I mean is are they on the top left, top right, bottom left, bottom right? Okay. So for our corresponding angle pairs, all right, angle 1 and angle 5 are a pair. And this is because they're in the upper left. Angle 2 and angle 6 are a pair because they're in the bottom left. Both are down here. Angle 3 and angle 7 are a pair. They're in the bottom right. And angle 4 and angle 8 are a pair because they're in the upper right. So that's what I mean by corresponding. Four angle pairs for corresponding angles. Okay, the next one you see is alternate exterior angles, and there's also alternate interior angles. So when you see this word alternate, alternate means opposite sides of the transversal. Opposite sides of transversal. So remember, T right here, this is your transversal. So in this case, for the transversal, I would say you have a left side of the transversal and you have a right side of the transversal because it's kind of going up and down. Okay. Now, I also see these words exterior and interior. So where is that at? Well, again, if this is line L and this is line M, then the interior is in between those two lines. This space right in here is the interior. That means that the outer regions above and below these parallel lines is called the exterior. Now, if we're looking at our alternate exterior angles, alternate exterior, so we're looking for the angles that are in the exterior, that would be 2, 3, 5, and 8. 2, 3, 5, and 8. And how are we going to link them together? Well, it's going to be an angle from one side across the transversal and in the other exterior position. So if 2 is down here, we're going to go across the transversal and then up to 8. Angle 2 and angle 8 are a pair. Same thing here. If we start with angle 3, we're going to go across the transversal and up to the other side. That's angle 5. So there's your pairs there. And then for alternate interior, we're looking at the four angles in the interior. That's 1, 4, 6, and 7. So now we're looking at 1 and again, jump across the transversal, but go up to the intersection point, 1 and 7. And now we're doing 4 and 6. And there we go. So these are these three types of angles when it comes to parallel lines and a transversal. Very important here. All right, next, the same side interior angles postulate. So the same side interior angles is another type of special angles. So here it says if a transversal intersects two parallel lines, then your same side interior angles, and when we say same side, we mean same side of the transversal, your same side interior angles are going to be supplementary. Right? So we abbreviate these SSINT, same side interior. So again, in this picture, here's your transversal, here's your parallel lines, right? We're looking for angles in the interior, so it'd be 1 and 2. And again, they're on the same side. So notice both of these angles are to the right of the transversal. Now notice in this picture, angle 1 we would classify as an obtuse angle, and angle 2 we would classify as an acute angle. So typically an acute and obtuse angle will add up to 180 degrees in a lot of these problems, right? And again, this is what it means to be supplementary. So to be supplementary, it means you add to 180. So let's take a look here real fast. So you can see that this is 60 and 20, 60 and 120. So 60 plus 120 is 180. Notice that these are not congruent, right? Because you have an obtuse and an acute angle, they're not going to be congruent. This is the only pair, as you'll see, that are not going to be congruent. Okay, so let's go ahead and explore using this Desmos. Give it a second to warm up. Good. So here we go. So I can take this point here and I can move these parallel lines. Notice here 180. 180 is 180, right? 75, 105. 75, 105 is 180. So same side interior angles are supplementary as long as the lines stay parallel. Okay, back to this. All right, let's keep on rolling. All right, so next problem here. It says, how can you express each of the numbered angles in terms of x? Well, if you see where x is, right? X is right here. It's an acute angle. All right. In this picture, you have two parallel lines, L and M, and you have transversal N. Transversal. So let's take a look here. So first of all, because these lines are going up and down, now this space right here is in the interior. Okay, and then the exteriors out to the sides. So let's just start in order. Let's go with angle 1. So how do I find the measure of angle 1 in terms of x? Well, if you look at 1 and how it compares to x, again, if you think of these two intersection points, angle 1 is in the upper left, x is in the upper left. They're corresponding angles. They are going to be the same measure because they're both acute. So angle 1 will also be x. And again, that's because they're corresponding. To find the measure of angle 2, let's see where angle 2 is. Angle 2 is right here. Angle 2 and x are in the interior, and they're both above the transversal. They're on the same side of the transversal. They are same side interior. To find them, they would be supplementary. So if you know x, you're going to take 180 and subtract x. And again, that's because they're same side interior. To find the measure of angle 3, angle 3 is in the interior along with x, but now they're on alternate sides of the transversal, opposite sides. So they're going to be alternate interior angles, and they're both acute. So angle 3 will also be x, and they're alternate interior. To find the measure of angle 4, well, angle 4 is kind of out here. Now, angle 4 and x don't share a direct relationship that we've talked about so far in this class. But we can see that angle 4 is obtuse and angle x is acute. So I'm going to assume that to find angle 4, you have to take x and subtract from 180, because if x is acute and 4 is obtuse, they probably add up to 180. Now we can use this idea. So angle 4 and angle 2 are vertical, right? 4 and 2 are vertical. They are created by these intersecting lines here. Those type of angle pairs vertical do not rely on parallel lines. So that's why they both happen. They both angles are at this intersection. And we can say that because it's vertical with angle 2, it's going to be the same measure as angle 2. If angle 2 is 180 minus x, so is angle 4. Angle 5 is not up there, so let's go to angle 6. Angle 6 is right here. It's right next door to x, so they're actually going to be a linear pair, which means they're going to be supplementary. And again, x is obtuse, so it's going to be 180 minus x. And again, they form a linear pair. Again, some of this vocab is from topic 1. The measure of angle 7, as you can see, is going to be vertical with x. So it'll be equal to x. And last but not least is the measure of angle 8. The measure of angle 8 here is, again, it's adjacent with x, next to x. It's going to be supplementary because it's a linear pair. So I would do 180 minus x. And again, they're a linear pair. Great. So again, this is a pretty typical problem you might see as well. Okay, let me go through the 3 types of angle pairs and then we'll stop this video. All right. Sorry if it's a little bit long. Okay, so the next one, the alternate interior angles. So again, they're kind of trying to introduce these things at the same time while explaining the ideas. So we just did some alternate interior angles. We talked about them in example 1. So if your transversal intersects 2 parallel lines, then your alternate interior angles are going to be congruent. And again, this word alternate is in respect to the transversal. So if T is my transversal here, one of these angles will be on the left, so angle 2 is on the left. One will be on the right, angle 1 is on the right. Again, they're in the interior space. And notice that angle 1 is obtuse, and angle 2 is obtuse. And they are congruent, which means they are the same measure. So in this picture, you'll see that 120 equals 120. If we did the angles next to them, so this angle would be 180 minus 120, which is 60 degrees. And this angle would also be 60 degrees, and 60 equals 60 as well. We can take this tool and manipulate it if we want to. So again, it's going to let me take the parallel lines and kind of move them. And you'll see that as the parallel lines stay the same, those angle measures stay the same. Perfect. Okay, next idea. Again, get 2 more. Are the corresponding angles. So again, we talked about the corresponding angles being in the same position, right? If the lines are parallel, then the corresponding angles are congruent. So again, remember, corresponding angles, which we abbreviate as CORR, are in the same position. So notice 1 and 2 are both in the upper left at their respective intersection points. So they are both going to be the same measure because they are both the same type of angle, obtuse and obtuse. So they're going to be congruent. Again, over here, you'll see 120 and 120. And if I take this tool and I start to manipulate it a little bit, again, you can see as the lines stay parallel, these 2 corresponding angles will stay congruent. 89, 89, 151, 151. Okay, and last but not least here, the 4th type of angle pair are going to be the alternate exterior angles. So alternate exterior angles are angles that are on opposite sides of the transversal. So again, this word alternate, right? Alternate means on opposite sides of the transversal, but they're in the exterior. They're outside the parallel lines. They're also going to be congruent, right? So in this picture here, again, here's your transversal. Angle 1 is on the left, angle 2 is on the right. They're both in the exterior because this is the interior. So 1 and 2 are outside that space. And we know that angle 1 is obtuse or looks obtuse. Angle 2 also looks obtuse. So these 2 angles will be congruent. And again, over here, we have 120 equals 120. They're on opposite sides of the transversal in the exterior. I can go ahead and take this and manipulate it as well, like so. So there we go. Right, alternate exterior angles are congruent if the lines are parallel. All right, so this stops the first video. The next video has 3 problems on it, some of them involving what are called proofs. Woohoo! All right, here they come.